Okay, I just wanted to record another screencast here just to finish up on one of those questions we were doing in class on Friday. We ran out of time, just so there's clarity on this. So I'm referring back to the example on page 485, example 21, where we've put this table of values in. We've got our headers at x and y. Okay, and we've plotted these points x and y, and we're having a look then. Therefore, we then go back into graphs and choose a scatter plot of it, and there it is there. And then we want to have a look at trying to well, we can see that this, firstly, it sort of moves in some sort of wave formation, be looking a little bit like a trig curve. So then we want to match it up using what we know about the trig transformations. So just to recap, maybe put something down on paper about this. I'm liking this to be a cos curve at the moment. So I think what we need to be doing is getting back. So we want to, we're talking about this in a cos graph, this thing here. So we want to know what goes into these four slots here. So let's go back to it. Firstly, I'm thinking I'm using this here as my guide point. This is my max point on the curve. I want to know where that occurs because that should be on the y-axis. So where does that occur? That is at 3, 9.4. So that tells me that this has been displaced 3 to the right, horizontal translation of 3 to the right, which means I need to be putting a -3 in there. -3 in there gives me a right displacement of 3, a translation to the right, a horizontal translation to the right of 3. So we've got -3 in there. The next thing we probably want to look at is the amplitude. We go from 9.4 here to 2.2 here. So going back into, so for amplitude, we've got 9.4 minus 2.2, so our extreme values, divided by 2. So 7.6 divided by 2, or 3.8. So that goes in to that slot there. Okay, the next thing we need to hold. Okay, just spotted an error there. Sorry, that should be a 7 point. That's incorrect there. That's a 7.2, and that's a 3.6. So it's a 3.6 amplitude. Next thing we can figure out is the vertical translation, and the vertical translation is going to be the maximum value minus the amplitude. That amplitude just slots in there, and the maximum value slots in there, so that we get 5.8. So that goes into that position there. So the last thing to do is to work out the period of the curve. The period of the curve is from max to max. Its horizontal distance there is from 3 to 9. So our period is equal to 6. Right, so 2 pi over b is equal to 6. So 6b is equal to 2 pi, and b will equal 2 pi over 6, or pi over 3. So pi over 3 goes in here. So I think our equation reads, if we just rewrite this as y equals 3.6 cos pi over 3 x minus 3 plus 5.8. I think that's what we've got, so I'm going to try that in here. So I'm going to input. Okay, so I've just gone and put this equation in that we've determined, 3.6 cos pi over 3 bracket x minus 3 plus 5.8, and you can see it maps beautifully to those blue data points. What I want to show you one more thing here, and that is go back to the spreadsheet where we entered our data, and if we can just, one of the options once we're in here, I've populated columns C and D, you can see, but this is how it was done, and I'll show you what it means in a moment. You can go into menu when you're in the spreadsheet, statistics and stat calculations, and what we can do is, one of the things we can do is these are all the options we've got for modeling or running a curve through some data points. So we obviously are looking at a quadratic, sorry, not a quadratic, a trig graph. So if we see all the options we've got here, linear, quadratic, cubic, quartic, we can pick our own power, exponential, logarithmic, sinusoidal. That is a sine curve. So if we check that, our x list is x and our y list is y, and click OK. We cancel this next box and we get a readout here of values. Now this is for a sine b x plus c, slightly different in that there's no bracket around the x plus c. That'll change our c value slightly, but you can see our amplitude is there at 3.6. 1.04 it reflects our pi over 3 value for b. C is slightly different because ours is in brackets, so ours is times multiplied by that 1.04, but that's the equivalent, and then 5.8 on the end for d. And then interestingly below that is how close this curve gets to those points. So this is like an error count. Now you can see that's incredibly low. It's 3 times 10 to the minus 15. So 0.1403 level of accuracy. So it's absolutely bang on. And if we move one of these points around, let's say went in here and changed this point to 2, then let's have a look at how that changes our residual value. You can see now it's at 0.1608, so the accuracy has been lost massively. And if we then went back in and had a look at the graph, you'll see that there's a point there that's now not so well represented by this graph, so it lost a bit of its accuracy. So that's going to be something of use to you, I think, when it comes time to do your own explorations and your own sort of modelling of a scenario that you've dreamt up. So I thought it was worth completing that exercise, that example, showing you one or two more features. All right, I'll see you back in class on Monday.